Very good morning to the participants. Welcome to the day 3 of the 1 week online faculty development program on blockchain technology and its applications. Today we are having Dr. Shanthi Makka madam for giving us talk on Ethereum blockchain and smart contracts. Professor Shanthi Makka, working as a professor in the Department of Computer Science and Engineering, Vardhaman Engineering College, Hyderabad. She completed PhD from Birla Institute of Technology, Ranchi, MTech from Galgotia College of Engineering, Greater Noida, Uttar Pradesh, BTech from Geetham University, Vishakhapatnam, Andhra Pradesh. She has 19 years of experience in academics and profound knowledge in blockchain technology, parallel computing, solidity programming, Python programming, algorithms, theory of automata, data structures, advanced data structures, compiler construction, object-oriented programming using C++, parallel algorithms, C language, logic design, computer-based numerical methods in C, Fortran and Pascal, computer graphics, database management systems, and core Java. Research interest areas are blockchain technology and theoretical computer science. She published number of research papers in international journals and conferences and attended multiple conferences at national and international level and also been a keynote speaker in various conferences. Authored a book on identification of parallel modules and also published book chapters in Springer and IGA Global. Worked as head of the departments in various engineering colleges and reviewed many research articles and worked as a PC member for conferences and also certified by NPTEL IIT Kharagpur on automata theory, data structures using Python, many certifications completed on blockchain technology through Coursera, RPA certified by Automation Anywhere, and delivered an expert lecture on theory of automata at the Dronacharya Group of Institutions under TechWhip Phase 3, organized various FDPs and workshops for the students and faculty members on Python programming, IoT, and automata. While coming to the research projects she submitted, or research proposals she submitted, first project, level 0 titled IoT based innovation library, innovation laboratory under the division R&D infrastructure submitted to the DST first, that is fund for improvement of science and technology worth of 1.1 crores. Project titled Eagle Eye using AI and computer vision is submitted to ICSSR, that is Indian Council of Social Science Research, worth of rupees 5 lakh. Like this, madam has a long profile. So we are very grateful to Shanthi madam to have as a speaker on this day. We welcome Shanthi madam to give a talk on the Ethereum blockchain and smart contracts. Thank you, madam. Please, you may start the session.
Yeah, very good morning all. And firstly, I just wanted to convey my thanks to Raghuvamsi sir and Naveen sir for giving this opportunity to share some of the knowledge what I'm having on a blockchain and blockchain. So it's my privilege to be to deliver today's session with all of you. I'm so happy to be. Okay, I think we can start presenting now. Shall I share the screen now, sir?
Sir, madam, you can share the screen and you can start, madam.
Is it visible, sir?
Yes, madam.
Okay. Okay. See, this 1.5 hour journey will take you, like you will be having a kind of idea about the Ethereum blockchain, When you talk about Ethereum blockchain, three things you keep in mind. One is it is a decentralized network. And second point you need to remember is the computers, the nodes which are placed on the blockchain network, they are peer-to-peer connectivity is there. The third point which you have to remember about the smart contract. I think my voice is clearly audible so that I can maintain the same level of explanation. If I'm because I'm a South Indian, I speak a little bit fast. You can stop me in between. So is that okay, everyone? Can you proceed
Yes,
with the
yes, ma'am. It is
presentation?
okay.
Yes, ma'am, it
It
is
is
okay.
okay.
Okay, thank you so much. Okay, the outline of my presentation would be like I'll give a bit introduction, and I was asked by Naveen sir especially that I need to have a hands-on session also. So I designed my presentation in such a way that half an hour I'll be dealing with the solidity programming, and rest of the time like what is like why do we need the smart contract and what is the Ethereum blockchain and all those information I will be explaining prior to the practical session. Okay, then what is Ethereum blockchain? I think hardly I'll take 2 minutes to give a history of Ethereum and what is the Ethereum virtual machine, and we go for an architecture. Then what is the smart contract and where the smart contract has to be practically executed. So there we talk about the Remix IDE. Then bit one or two slides about the Solidity introduction. Then we go for the practicals. Examples means practicals. As I said that initially, like when we are talking about Ethereum blockchain, I said you to remember three key terms. One is about the decentralized, and second I talked about the peer-to-peer network, and third I talked about the smart contract. So I would define the Ethereum as a decentralized blockchain platform and which establishes the peer-to-peer, like every node will be connected to each other. And see, like whenever a new node is wants to take a part into our blockchain network, by the time there should be like anybody cannot take entry, like everybody can't take an entry. So we need to have certain verification approach. There we talk about the smart contract. It is a smart contract is nothing but it's a kind of a agreemental terms. But here the agreemental terms we keep it in the form of some instructions. As you know that like as we all belongs to the CSE field or any field, it's okay. Like if it happens, this should be executed. So such kind of instructions we place it in the as a part of the smart contract, and this smart contract never expect any third party to interfere. Like suppose if I'm making some transaction with a node Y, if I'm the node X and if I'm making a transaction with a node Y, so it is between the node X and node Y. We have certain what to say agreemental instructions. Those instructions we write it, and those instructions automatically get executed. So we don't need any third party to establish or to create a trust between the peer nodes in the blockchain network. Okay, as I said that the smart contracts allows the participants to transact with each other without trusted central authority. Then no one is there, no bank, no financial industry, nothing will be there in between us. Now, when I talk about Ethereum blockchain, it is an open source blockchain only, and basic functionality will be we will be using the basic functionality of the smart contract to create the trust. Okay. Now, when we talk about blockchain, means first term which comes to our brain, our mind is about the cryptocurrency. We are aware the famous cryptocurrency is about Bitcoin, and I think today morning I have seen today I think one Bitcoin cost is around 16 lakhs. I'm talking in terms of INR, and Ethereum is the second most common famous or the familiar cryptocurrencies. It has around 1,37,000 or something. And why I'm saying today morning, because it keep on changing. The value will be set up by certain miners. It will be keep on changing based on the demand. Okay, and you don't believe that this Ethereum, the concept of this Ethereum blockchain or Ethereum has been invented by one of the person I'm talking about, a 19-year-old boy who is he is Mr. Okay, just give me a minute. Okay, who is Mr. Vitalik Buterin. I just got a little bit a small photograph so that you can just see him. He is a Russian Canadian programmer, and when he was one of the like co-founder of the Ethereum, and when he started, when he got this idea, I think 2013 or 14, he got this idea. So by the time he was 19-year-old, and he has a team of people. These are all like if you surf on the internet, you get Mr. Vitalik name and that Gavin Wood name. But there's a few more team members are there. And in 2014, when they got this idea into their mind, so they went for the crowdfunding, like some like crowd of people who can fund their idea. And then after that, the entire network was live on 30 June 2015, but official release was done in the 2016 March. This is an Ethereum symbol actually, the logo. This is a bit history with the timeline. Now, when we talk about Ethereum virtual machine, it's a kind of runtime environment to execute the smart contracts, on the Ethereum blockchain. Okay, and this EVM basically concentrate on the security as well as the executing the code. And this code is like we do not have any trusting criteria. So it is, we would call it as untrusted code. And by all the computers, like thousands of computers are connected to each other. Okay, but this runtime environment will be provided by the EVM, Ethereum virtual machine. Okay, now here you can see like a virtual machine. Ethereum virtual machine has been designed to serve as a runtime environment for the smart contracts based on the Ethereum. Okay, now what blockchain does Ethereum use? Okay, the Ethereum blockchain actually it has a native currency as ETH. That is, in short we call it as ETH. It is an Ether, and it enables the developers. The developers can create their own the new type of Ethereum currency based on the tokens that power the decentralized applications using the smart contract. And one most common Ethereum based cryptocurrencies which are built on the token standard called ERC20. This is Ethereum request for comment. And this actually most frequently asked like what is ERC20? It is a kind of standard to create and to issue the smart contract to the or on the blockchain network. Am I connected to this? I'm not able to move forward. Okay, okay. So suddenly I think it got stuck. I'm just coming back now. Is it okay fine now? Okay, sir. Maybe a network issue, even it got stuck. I was just talking. Yeah, this I'm talking about ERC20. This I will not elaborate much, but this is a kind of a standard which is used to create as well as to issue the smart contract on the Ethereum blockchain. Now let's talk about the Ethereum architecture. Because as we talked about, like multiple, the thousands of nodes are connected to each other on this Ethereum blockchain. Like what are the basic what are the basic components of the Ethereum node on the network. Like I'm just calling that a computer as an Ethereum node. What are the basic components it has? And here you can see like Web3 API we have, and basically the role it has general knowledge. You may be aware that it is like collection of JS libraries only, and through which we can access the Ethereum node remotely as well as the locally also. And basically it provides a connection between the Ethereum node and the smart contract. Okay. Now the different components are, one is like smart contract, which we will be having depth knowledge along with the implementation afterwards, and Ethereum virtual machine. Already we talked about it, is about the runtime environment to execute our smart contracts on the Ethereum network. And another term here you could see here as gas. Gas is nothing but like whenever I make certain transaction on the blockchain network, and that to process the cost needed to process the cost needed to process the transaction is called as the gas. The value for the gas is set up by the miners. The value for the gas is set up by the miners. Okay. Then, and that also, like all the time the gas value cannot be fixed as same. Like miners will see that how much demand is there for the computational power of the blockchain network. Accordingly, they decide the fees for the gas, the value for the gas. Okay. Now, one more important point here, you can see here, Ethereum blockchain in bracket I have written world state. What is this world state? What it contains? The world state contains the current values of the ledger states. Ledger means it's a kind of database. Okay. The current values, like suppose if any programmer wants to get the current, what are the current values of the ledgers in the ledgers, then by the time the programmer no need to traverse the entire network. What the programmer can do, simply he or she can refer to this world state, and which gives it instantly you can get the values. Okay, these are the current values, so that accordingly they can proceed further. These are all I have explained over there. And one more point I need to emphasize here, if any node, if I'm treating that node as an Ethereum client, that node must be capable of verifying the new transaction. It also must be able to execute the smart contract, and it also must be able to process the new block for the chain. Now, I just wanted to explain one small example, transaction life cycle uh, using like on the Ethereum blockchain with by taking an example of voting, by taking an example of elections, like voting we do during the elections, you know. So that small example, I will not take much time on theory part. See, as a user, suppose if I'm using some web application, it looks like, okay, these are the elections. There, the 4 candidates are contesting in the elections. So what I do is I just select one of the candidate and just click on this vote button. Then I get the message instantly like your vote has been successfully submitted or something like this. Okay. So as user, I have this idea, but uh, just clicking on this vote button and getting that message, in between that process there is a chance of getting some like manipulations. So to how to handle such manipulations, or could not, like how can we handle such manipulations so that proper voting with the voting can be conducted with the consistency, like how can we do it? First, what we do, like we have the moment, like we write this is a web application. For example, we have written this web application using the JavaScript, a small segment I have taken here. Okay. Now here this web page JavaScript, we, for example, I have a function called cast vote. Okay, I just wanted to cast my vote. So the moment when I call this function, okay, uh, by the time the transaction is being created, because the transaction is here, I clicked on vote. Clicking on vote doesn't, that means that I just called a function cast vote in my JavaScript. Okay. Here what I will do, that moment only, one transaction is being created, and along with the transaction, for the authentication purpose, the digital signature also will be there. Okay. Now, once the transaction is being created, it will be propagated and it will be given to the peer node. Okay, some local Ethereum node. Now, what is the role of this Ethereum local Ethereum node? Is that uh, local Ethereum node must be able to validate the transaction. How it will going to validate? Because as I said that once the transaction is being initiated, by the time the digital signature of the sender also will be there. Okay. Now, here the local Ethereum node must be able to validate like whether the digital signature is consistent with the sender address, or is it consistent with the what to say transaction information. Not only that, the third point, this local node must also be able to check whether the sender is having a enough fund so that this transaction can be successfully completed. All this information will be verified. In case there is no fund, here itself this information, this transaction will be terminated. It will not be further propagated to the peer nodes. Okay. Now, once it is propagated, there are like not only the peer nodes, we do have a mining node who plays the major role, like who validates your transaction, who processes your transaction means who is going to introduce the new block. If it is validated, then the new block will be added here. Then the transaction is placed on the new block. That block is propagated to the peers. Okay. Once this particular block has been validated and executed, propagated to the peers, then the vote confirmation will be done. Then that message, like what we get, like successfully you have done, that will get displayed. In this way, the blockchain network can be utilized. The Ethereum blockchain can be used to handle the web application, like for voting purpose. Like you can see, like many use cases are there which are relevant to finance and which are relevant to some medical and all. And if you have any queries, you can put your queries in the chat box. I'll be handling once I'll out of the session. Like once I complete my presentation, I'll be handling the queries. Now we have enough knowledge about the Ethereum blockchain. Then we talk about that the Ethereum blockchain works under the functionality of smart contracts. So now we need to have some idea about the smart contracts. Basically, like as I said, that is like suppose if two parties are two different nodes or two different persons are wants to make certain transactions. By the time that legal agreements, like I wanted to, for example, if I want to sell my property, then I will be like, this is my quotation for selling my property. Others will be going to this. All this contractual instructions will be written in the form of the coding. So it is, I would call it as it is a replacement for the traditional contracts. Okay, and this is authority-less autonomous program that directly controls the numeric securities. These securities based on the mutual agreement terms. This we already spoke about. It's just like at the beginning, like when I was giving an introduction, I was talking about it just like if this happened and this is the way. In this way, we have to like if then clauses how we use in the programming language. In that way only we are going to make our instructions in the smart contract. It is a digital form actually. And at this point we got an idea already. Smart contract also we have. And the concept of smart contract was first proposed by Nick Zobo in 1994. He was like a legal scholar, and he is a cryptographer known for laying on groundwork for digital currency. Now, how the smart contracts works? For example, as the Bob and John, like Bob wants to sell his house, his property, and John wants to buy certain property, a certain house. So now what, like their needs they will be putting in the form of a digital form, and John needs also he can. Now like John, when he wants to buy the property or he wants to buy the house, by the time as Bob has initiated his transaction of selling his house. So in the transaction, the smart contract will be there. If the agreements, whatever he is expecting and whatever he is expecting, if their agreements are matches to each other, so by the time the smart contract distributed, the smart contract can be used to distribute this assets. Here we can see like we have not involved any third party. Like in layman language, we call like we need to approach some consultant or some brokers and all. All those things will not be there. And while initiating the transaction by the Bob, the ownership and everything, like that property should not be any, it should not have any disputed ownership and all. All those things will be verified by the nodes in the network. Like you know that when I have to add a new node into the blockchain network, that particular node has to be agree the term that should be accepted by all other nodes in the network. Okay, so here the complete land deed is being digitized. Now, what are the characteristics of the smart contract? The basic characteristics are self-enforcement, self-verification, tamper-proof. Self-enforcement means, as I said, that the instructions will be between the sender and the receiver, and the instructions once they write, they will get executed by themselves. They will get executed by themselves. We don't need anybody else to execute this. So that's the reason I would call it as self-enforcement. Self-verification means, like, suppose, okay, deal is done. Suppose if I have a deal with some vendor, okay, the vendor is required to send me the required products within some time span. But vendor was not able to provide those products within the time span. My smart contract will be able to even propose a fine. Like, okay, if the deal is not done within the given time span, then this much of fine has to be given by the vendor. So this automatically it will verify whether the timelines were met, which was decided during the when they signed the smart contract. Okay, it was not met, then immediately that whatever the terms and conditions that will get verified and it will be fulfilled. And once the main drawback also, I would call it as one of the characteristic of the smart contract, once the instructions were written, it cannot be updated. Okay, it is immutable. So that's the reason it is tamper proof. Nobody else can be. But in fact, if we want, in case certain times, like at the beginning, we made certain yeah, like agreements between with some company or some vendor. But afterwards, if you want to go for any additions or something, by the time what we do is again the new transaction has to be initiated, and that should be agreed by each and everyone. In that way only we can do. So it is more secure. That's the reason we would call the smart contracts as a tamper proof. So this explanation we have done with it. So these are all the advantages of the smart contract. It is immutability characteristic. Once we have written, it can't be changed. Now the problem comes, okay, it is written, but what about if some bug introduced in the smart contract? That is an issue with the smart contract. Autonomy and automaticity. See, autonomy means automatic, what to say, like no third party interference, and automaticity means whatever the instruction we have written, it automatically it will get executed. Okay, so it reduces the audit and execution cost as well as the fraud. Benefits, like as you do not have any third party, obviously you are saving. And as you know that this particular information is, all the documents are shared among all the nodes in the blockchain network. So multiple duplicated copies are available with us. So backup is always there, and it is safe because the smart contracts are encrypted, and cryptography keeps all the documents safe from the infiltration. And speed, because automatic execution, no need to wait for someone. Once okay the transaction has been initiated, we can just go for automatic execution, so it improves the speed. That means we are saving the hours of our business processes. Accuracy, like as using smart contracts, We can eliminate the errors that occur due to the manual filling of any numerous forms of the data and something. Difficulties once we made certain terms and conditions, it's very difficult to change. If I have to go for changing again, as I said that again we have to make a new request and again taking an acceptance of all the nodes in the network. So it will take time consuming and all. And even since the smart contracts reduce the dependency on the like third party, that means like lawyers and all. So by the time like legal consequences we should be able to handle. And transactions, delay transactions, suppose if something happened, like any congestion or any problem is there, then there may be a chance of delaying the transactions also. So I would say that the smart contracts will not be suitable for all kind of situations because when you talk about the legal aspects or legal deals, by the time it's better to be like court involved and many things involved. So still this area the people are working, but still here the contracts are getting filled. Like actually, the smart contracts concept gets succeeded when we have okay the results, the outcomes are decided objectively. So it's a small difference between the traditional contracts and the smart contracts. Like traditional contracts means the manual power included, so it takes 1 to 3 days or more than that also. And as it is automatic execution, so it takes a minutes of time. And manual remittance, like the payment will be done on manual in some cases. Here the payment mode will be automated. Here like when I'm doing a traditional contracts, there will be a bonding and all. A bond will be written like this many years and something. Here there is a bond is not compulsory in the smart contract. And if you talk about traditional contracts, here big expensive because many people involved to get settled down the things, and here fraction of second, and it is less expensive. Okay, then obviously like physical presence, and here it is virtual presence is sufficient. Lawyers are necessary, lawyers may not be necessary in the smart contract. Now, use cases for the smart contract, these are few use cases I got it. One is like intellectual property rights. Intellectual property rights. Here, we use the concept like as you know that when we are moving, almost we have moved most of the things on the digitalization, but moving to the digital world again, creating, increasing the fraud also. So here I can think of using the smart contract to come out of this that kind of fraud system. Here we use the concept of NFT, non-fungible transaction. Here what we token, sorry, non-fungible tokens. What we do is NFT means we'll define this NFT for the unique ownership. I'll call it as unique ownership. So NFT is used and many like companies have started using this, and I'll be showing one small slide where use case of Deloitte company. I just got it from their website. You can just see that what are the areas they are using the concept of smart contract. Okay, so they will not be having a clear, they will not be giving us a clear-cut idea that how they are using, but where they are using that information. I got it in the form of tabular form. Here, intellectual property rights, we are using NFT, and for the property rights also, here also like the smart contracts is being used, and chain of contact or custody. What is chain of custody? Like I think I'm continuously speaking. I think you people are getting bored continuously. I'm speaking. Okay, sir. Within I think after 10 minutes we'll start.
No, madam, it's interesting, madam. It is interesting. We are gaining, like once we'll implement it, so it would be more
Yeah,
interesting.
that will start after 10 minutes, sir. But actually, bit the
No, no,
theory.
madam.
I need to give an introduction. No? That's the reason.
Okay, ma'am. Okay.
Okay. I thought some queries there. These are the different areas where the smart contracts are being used, and this is, as I told you, like JIIT is implemented the smart contracts in these are the areas. These are the services what they're providing in financial services, life sciences and healthcare, technology, media, telecom, and public sector, cross industry. These are all the areas like this information I got it from the JIIT website only. The PPTs I'll be sharing with the Raghuvanshi sir so that you can go through it afterwards. So at a glance, if I have to talk about the smart contracts, like this is a code which runs on the blockchain. It is immutable once we have written the instructions, once we have written the incremental instructions, those cannot be changed. Generally, we say like that, but if I have to edit, then again I recreate the new no, a new transaction, and in that way we can go for the edit and all. But generally, it is not possible, and it is highly secure. No third party involvement or something, and the languages which we use to write the smart contracts are the Solidity, Rust, JavaScript, Viper, and these are all. But today's session we will be talking about, we will be having a practical session on the Solidity only. Actually, this Solidity is a like object-oriented high-level language, which got the most of the features from the C++, JavaScript, and Python. Now, okay, once I write my code in using the Solidity, like I need to have some environment like some IDE to execute my Solidity program. For that, we have the Remix IDE, and this Remix IDE, it can be we can use it like web-based application or the desktop application also. But I'll be using the web-based only so that you people also simultaneously practice along with me. Then it is an open source tool and which helps to write the Solidity contracts straight from the browser. And it is written in, I said that it is written in JavaScript, and this browsers, we can use it, this Remix supports the both users in the browser as well as the locally. That means like the desktop application also I can have it. And it supports the testing, debugging and deployment of the smart contracts. And please kindly make a note of this. This is a URL, like it is a web-based platform I'm going to use to write the Solidity programs. Kindly make a note of it so that I'll just connect it directly. Can I proceed further? Okay. And Solidity is object-oriented or the contract-oriented high-level programming language to implement the smart contracts. It is highly influenced by C++, Python, and the JavaScript. Okay, and it's been designed to target the Ethereum virtual machine, and it supports certain object-oriented concepts like inheritance. But see, this today's session we'll be having a small examples only because we need to have a complete idea. Then afterwards, once you have once you begin with some of the programming language, you can just with the practice you can further go for the project implementations and all. Then we can use the Solidity to create the contracts for users such as voting, crowdfunding, blind auctions, and multi-signature wallets. Okay, when I'm writing a program in Solidity, as like in C or C++, we include our header files. Okay, first line of our code will be having a directive called pragma, P-R-A-G-M-A, pragma. We have to include this directive. Through this directive, we can include our Solidity compiler into that version of the Solidity compiler into the program. Okay, and it's a kind of new language, but I don't think so. Like if the people who knows the JavaScript, they don't at all find it as a new language. There are certain functions like pure and view. These examples I will be discussing on the practical only. So let's go for the practical.